If you've spent the last couple of years, like most companies, really carefully building out your generative AI strategy, you've probably been laser focused on things like data safety, model governance, maybe IP protection.
All the usual suspects.
Exactly. But what happens when the whole landscape just shifts under your feet?
Mhm.
Where we move from these experimental AI tools to fully integrated agentic AI ecosystems.
Well, that's where we are now. And it's a completely new frontier where attackers are, frankly, less interested in your data.
So what are they after?
They're interested in your ability to compute, your capacity for intelligence itself.
And that's the heart of the shift we're seeing.
It is. We are now seeing the emergence of this sophisticated resource-based exploit that the Intel community is calling LLMjacking.
LLMjacking.
Yeah, it's just the unauthorized hijacking of the infrastructure that powers large language models, or even the LLMs themselves, using stolen credentials to get at that really high-value cloud compute.
And this isn't just a theory, right? This is happening now.
Oh, this is not theoretical at all. This comes straight from Idris Iklek's big 2026 report on threat intelligence and the AI supply chain. It really demands a whole new way of thinking for defenders.
So for you listening, our mission with this deep dive is to unpack the technical mechanics of an LLM-jacking attack. We want to understand its role in this bigger AI supply chain, which has 4 layers, and analyze why we need to move beyond traditional tools.
Things like CSPM, cloud security posture management, just aren't cutting it anymore.
Right. We need to address these invisible compute thefts. By the end of this, you should have a solid grasp on this new paradigm of agentic agency abuse.
A pretty important concept to get your head around.
Okay, let's start with some history. To really get why LLM jacking is such a huge threat now, in 2026, we have to look back a few years at how resource theft used to work in the cloud.
You're talking about cryptojacking.
Exactly. Back in the early 2020s, that was the big buzzword, cryptojacking.
Right. And cryptojacking was all about stealing generic CPU and GPU cycles, usually for mining Bitcoin or Ethereum.
It was a theft of utility cycles.
That's a perfect way to put it. Stealing raw processing time for a decentralized, pretty low margin purpose, really.
But the underground economy doesn't stand still. The economics have shifted dramatically. Why is LLM jacking so much more profitable, so much more strategic than cryptojacking ever was?
Because the resource itself has fundamentally changed. Generic compute is, well, it's commodity.
You can get it anywhere.
But what's really scarce, what's incredibly valuable, is high-performance LM compute. That specialized, optimized GPU time you need to run massive models or fine-tune something proprietary.
So you're not just stealing electricity anymore.
Not at all. You're stealing the keys to an incredibly expensive R&D lab and a high-capacity content factory all in one. The attacker gets this super specialized intelligence capability completely for free.
And for defenders, this is the big mental shift. A traditional breach is about data exfiltration, stealing customer lists, source code.
Right.
LLM jacking is primarily about resource consumption. The data doesn't even have to move, but that bill just keeps going up.
That's the critical distinction. The attacker forces the victim to unknowingly finance these huge, expensive AI workloads. We're talking about generating thousands of hours of video or fine-tuning some custom model with illicit data.
All through legitimate services like OpenAI, AWS Bedrock.
Exactly. Anthropic, Azure, OpenAI, you name it. The cloud provider correctly bills the victim's account because, well, the API key was valid, so the attacker profits, and the victim gets hit with a massive invisible charge.
It really exploits this kind of trust by default nature of all these API integrations. Our sources lay out a really consistent 3-step attack chain for this. Let's start with step 1, credential harvest.
Okay.
Where are these attackers finding these golden keys?
The main targets are still developer environments because, honestly, they tend to be a mess.
Less lockdown than production.
Way less. Security is so focused on the prod environment that testing and staging are often wide open. And the research from the last year or so shows this huge surge in automated secret scanning bots.
And these aren't just generic scanners.
No, not at all. They're specifically trained to find AI credential patterns.
So they're looking for specific fingerprints almost. What kind of patterns are we talking about?
They're hunting for things that scream AI key, like the scamp prefix for Anthropic or specific headers like AKI, and they look in all the usual messy places.
Public GitHub repos.
Public GitHub repos are a goldmine. Also, container images with secrets baked right in, CI/CD logs that just dump all the environment variables, and, the classic one, improperly secured .env files just sitting in a public cloud storage bucket.
So once they find a key, that takes us to step 2. Verification. The invoke model probe. You can't just fire up a $10,000 workload immediately, right? That would set off all the alarms.
Exactly. It creates too much noise, too many cost-based alerts, so they have to verify the key is live without making a splash.
How do they do that?
This is the really ingenious part. The report calls it the 2026 validation exception technique. Instead of sending a normal, expensive prompt like, write me an essay, they submit totally malformed or logically impossible parameters.
Like what?
The source gives a perfect example. They'll set a constraint, like max tokens equals mesh 1.
Which is brilliant.
Yeah.
Because that's not a malicious request, it's just an error. I'd probably ignore that alert.
It's the perfect low-noise signal. The system has to process the key first, check the access, then it runs the logic check on the parameters. And since you can't have negative tokens, the API just returns a validation error.
Okay. So if the key was dead, it would say access denied. But a validation error means?
It means the key is active and authorized. You've confirmed it's live without running a real workload, without using a single second of GPU time, and without spending a penny of the victim's money.
It's like quietly checking if a door is unlocked instead of kicking it down. Which brings us to step 3, exploitation and monetization. So they have a live key. How do they turn that into cash?
We see 3 main paths. The first and simplest is they just run private AI models. They're basically hosting their own attacker-controlled LLMs on your infrastructure.
Turning the victim's cloud into their own private free AI server farm.
Pretty much. That saves them a fortune in infra costs. The second path is model reselling.
So they become a provider themselves.
Right. They set up these shadow APIs or reverse proxies and start reselling cut-price AI access on the dark web. They're running an illegal cloud service that you are paying for entirely.
And the third way, the one that feels more strategic, targeting R&D capacity.
That's fine-tuning abuse. This is where they use that enterprise-grade compute power, which is often the really high-performance stuff, to fine-tune their own models. They can use stolen or illicit data to create incredibly powerful custom AIs without paying the massive training costs. They're stealing the very capacity to create intelligence.
Which is a good transition because LLMjacking isn't just a single vulnerability.
No, it's a symptom. It's a symptom of this huge fragmented AI supply chain. By 2026, we're basically dividing the supply chain into 4 distinct layers, and each one has its own jacking risks.
Okay, let's walk through them. Layer 1, the infrastructure layer. This is the bedrock, right? The cloud platforms, the GPUs.
Wow. Correct. And the main risk here is something cloud security folks already know, but the stakes are just so much higher now. Over-permissive IAM roles and credentials that live way too long.
A key that can spin up 1,000 GPUs and last for a year.
It's a jackpot. It's a sustained, long-term theft operation just waiting to happen.
Okay, moving up. Layer 2 is the model layer. This is where you get your pre-trained models from places like Hugging Face.
And here the big risk is model poisoning. An attacker can embed malicious behaviors right into the weights of a model that looks totally benign.
Like a Trojan horse.
Exactly. So when your organization runs the model for a legitimate reason, that's called inference, a malicious trigger could fire and exfiltrate environment variables or even other credentials from the host system back to the attacker. The model you trust is stealing your keys.
And even if the model is clean, there's layer 3, the data, or AG layer. ARG is retrieval augmented generation.
It's where the AI uses your internal documents to make sure its answers are accurate and relevant to your company.
But that data can be a vulnerability.
A huge one. This is where we see the threat of indirect prompt injection. The attacker doesn't type a malicious command. Instead, they poison a document, a PDF, a spreadsheet with invisible text that only the AI reads.
And when the AI ingests that doc to answer a question,
the poisoned text manipulates the system's behavior. It can trigger data exfiltration, maybe create a new user. The AI trusts the document, so the internal data itself becomes the weapon.
Which brings us to the final layer, layer 4, the agentic layer. This is the new frontier.
And the risk here is all about velocity. We're talking about autonomous agents, AIs, that can execute code, make decisions, chain actions together without a human in the loop. The risk is what we call excessive agency.
An agent that's trying to be helpful but goes too far.
Precisely. To complete a task, it might create new cloud resources, new roles, new identities, all without oversight. It just starts churning out credentials.
And that creates this massive, invisible sprawl.
A sprawl of what we call non-human identities, or NHIs. It creates these opaque chains of credentials that make it almost impossible to trace where an abusive request actually came from. You're not following a person anymore, you're following a permission created by a machine.
Let's make this real. The sources have a perfect case study. The 2025 token drain incident. What's so shocking about this one?
Just the scale of it. It was a mid-sized Canadian fintech. They suddenly found an unexpected $140,000 monthly cloud overage.
140,000.
Can you imagine that security meeting? They spent weeks looking for a data breach, a misconfigured database, and found nothing.
But it was pure LLMjacking.
Textbook case. They finally traced it all back to a single leaked API key from some non-critical internal testing environment.
Right.
An attacker found it, used that silent verification technique, and then just routed a massive deepfake generation workload right through the company's AWS Bedrock account.
So the victim was paying a six-figure bill for the attacker's illicit content factory.
And the scariest part is how they found out.
The invoice.
Only when the invoice arrived. Because they had no AI-specific security controls, no AI SPM. Their traditional tools were completely blind to it.
And that's the core issue, isn't it? Why do traditional defenses like CSPM just fail here? The sources point to three structural blind spots.
Right. First is the problem of legitimate traffic profiles. Your web application firewall, your WAF, it's looking for SQL injection, for malformed packets.
It's not looking at the content of the prompt.
Not at all. An LLM request is just a standard HTTPS JSON payload. It looks perfectly clean. Whether the prompt inside asks for a poem or for 10,000 fraudulent emails to the WEF, it's indistinguishable.
Then there's the second problem, the identity gap.
This is a big one. So many organizations, just for convenience, use shared or master API keys. If 50 different apps use the same key and one leaks, you have no idea who or what is making the abusive request. You lose all attribution.
And third, looping back to the agents, is non-human identity sprawl.
Exactly. These autonomous agents are constantly creating new credentials, new identities. You get these opaque chains of permissions. Tracking the true source becomes almost impossible because you're chasing a ghost in the machine.
So if this thread is becoming autonomous, what's the next logical step? The source outlines a pretty terrifying hypothetical, the agentic worm.
The agentic worm is really the ultimate expression of agentic agency abuse. It's self-propagating agentic malware.
So an AI designed to attack other AIs.
At machine speed, it would infiltrate an AI environment, enumerate all the connected agents and services, and then, this is the leap, it would manipulate peer agents into giving up their credentials or making new ones.
And then it just spreads.
It propagates laterally, across organizations, across supply chains. You end up with a cross-enterprise AI resource botnet that operates with almost no human involvement, just constantly growing its compute power with stolen resources.
That is a true nightmare scenario. So we have to talk about the defensive roadmap. How do we start to secure this?
It requires a big conceptual shift. You have to start treating AI credentials as critical infrastructure assets, not just developer conveniences.
So the first step is getting away from those static, long-lived API keys.
Absolutely. We need to move to short-lived credentials, identity-bound, time-limited tokens. If one leaks, the window for abuse should be minutes or hours, not months.
Okay, what's next?
Second, you have to attack the financial incentive with AI budgetary guardrails. This means strict, enforced usage caps per key and per agent, not just at the total account level. You stop a $140,000 drain before it even hits $1,000.
And finally, that invisibility problem. How do you see malicious intent inside what looks like normal traffic?
You need semantic logging. You have to augment your traditional logs, which just show an HTTP request, with AI-assisted analysis of the prompt's intent and behavior. You need AI to police AI.
So you're not just logging that a request happened, but what it was trying to do.
Exactly. And finally, you have to maintain a comprehensive AI supply chain inventory, an AI bill of materials, an AI BOM that covers every model, data set, and agent you use so you know exactly where everything came from.
To wrap this up, it really feels like LLMjacking is the first true resource jacking threat of the AI era. It's a huge shift from stealing data to stealing intelligence capacity itself.
That's it. And organizations have to evolve their visibility and control at the same pace that these systems are evolving into autonomous agents. The pace of that evolution is the whole challenge.
A perfect way to put it.
Yeah.
So for defenders, the lesson here, and the thought we'll leave you with, is this. You cannot secure what you cannot see. And in the age of agentic AI, invisibility is the attacker's greatest advantage.